Lecture 3.5, Derivatives of Trig Functions. This is Bryce Canyon National Park in Utah. Consider the function y equals sine theta. We could make a graph of the slope. So we make a table of theta and the slope. At negative pi, it appears that the slope is negative 1. So we'll put a dot at negative 1. At negative pi over 2, the slope is 0. When theta equals 0, the slope is 1. At pi over 2, the slope is 0. And at pi, the slope is negative 1. Now we connect the dots. The resulting curve appears to be a cosine curve. Since the derivative of a function gives a slope, it appears that the derivative of the sine function is the cosine function. We can confirm this using the difference quotient formula for derivatives. F prime x equals the limit as h goes to 0 of f of x plus h minus f of x over h. So in this case, it becomes the derivative of sine x equals the limit as h goes to 0 of sine x plus h minus sine x over h. Using a trig identity, we have the limit as h goes to 0 of sine x cosine h plus cosine x sine h minus sine x over h. We factor out a sine x, giving us limit as h goes to 0 of sine x times cosine h minus 1 plus cosine x sine h over h. Separating the two halves, we get limit as h goes to 0 of sine x times cosine h minus 1 over h plus cosine x times sine h over h. So here we recognize two limits that we've seen earlier in the course. The limit as h goes to 0 of cosine h minus 1 over h and the limit as h goes to 0 of sine h over h. We separate out those limits and get sine x times limit as h goes to 0 of cosine h minus 1 over h plus cosine h times the limit as h goes to 0 of sine h over h. The first limit becomes 0 and the second limit becomes 1. This gives us sine x times 0 plus cosine x times 1, or just cosine x. So we have the derivative with respect to x of sine x equals cosine x. we can do the same thing for y equals cosine theta. At theta equals negative pi, the slope appears to be 0. At negative pi over 2, the slope is 1. At theta equals 0, the slope is 0. At pi over 2, the slope is negative 1. And at pi, the slope is 0. Once again, we connect the dots. The resulting curve seems to be a sine curve that has been reflected about the x-axis. We can confirm this mathematically. Once again, we use the difference quotient formula for derivatives. F prime of x equals the limit as h goes to 0 of f of x plus h minus f of x over h. So the derivative of cosine x is the limit as h goes to 0 of cosine x plus h minus cosine x over h. Using the formula for cosine of a sum, we get limit as h goes to 0 of cosine x cosine h minus sine x sine h minus cosine x, all over h. Now we factor out cosine x and get the limit as h goes to 0 of cosine x times cosine h minus 1 minus sine x times sine h all over h. We separate the fraction into two parts, and once again we see that we have familiar limits from earlier in the course. We separate out those limits, and then evaluate the limits. The limit of cosine h minus 1 over h is 0. The limit of sine h over h is 1. So we have cosine x times 0 minus sine x times 1 or negative sine x. So we have the derivative with respect to x of cosine x equals negative sine x. We can find the derivative of tangent x by using the quotient rule. Start with the derivative with respect to x of tangent x and rewrite it d dx sine x over cosine x. Now, using the quotient rule, we have the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator over the denominator squared. So the numerator becomes cosine squared x plus sine squared x, and we recognize that as the Pythagorean identity. So we have 1 over cosine squared x, and since 1 over cosine is secant, this becomes secant squared x. So the derivative with respect to x of tangent x is secant squared x. Derivatives of the remaining trig functions can be determined the same way. So we get the derivative with respect to x of cotangent x is negative cosecant squared x. The derivative with respect to x of secant x is secant x tangent x. The derivative with respect to x of cosecant x is negative cosecant x cotangent x. And there's our complete list.